Let's try our program that has a somewhat more interesting loop. We declared a variable x, started x as 1. While x is less than 64, we're going to use while true. Then we're going to display whatever x is, and here x is x times 2. X gets x times 2. In the simpler loop, all we did, and I'll put this right here, was 1 to, say, 64, do, then with some value, and we printed that value. The problem with this is, well, this is just going to go 1, 2, 3, 4, 5, blah, 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 up to 64. If we wanted to do something more interesting, like multiply by 2 every time, there might be some built-in method that I may or may not know about to do that, but it's certainly not obvious. It's not at top of mind. When you just want to loop over numbers one by one, this is perfectly fine, but if you want to be very clear about what you're looping over, then this form makes it quite obvious. Well, I'm starting from 1, so long as the number is less than 64, I'm going to multiply by 2. We can run this code to verify that it does indeed work. 1, 2, 4, 8, 16, 32. Those are the first 6 powers of 2, including 2 to the 0. And if we change this code a bit, we can, of course, end up with an infinite loop. Now that's going to be 1 forever, because, well, and I eventually interrupted it, which made Smalltalk quite unhappy with me. That's going to be 1 forever. And, of course, we could change how we change x. And just like infinite loops in any other language, if your condition and your increment don't correspond, so it doesn't eventually become false, well, you'll also be in an infinite loop. Smalltalk is very unhappy with me. Just don't do infinite loops. Smalltalk doesn't like it. So let's go back to this version. And the interesting thing to note here is when we were just checking a condition, we didn't put this in a block, but that meant we would do that check exactly once, because then we're passing if true to the Boolean object that was the result of this comparison. So x is less than 64 returns a Boolean, then we call if true on that. But that means we've already done this computation. We're done with it. It's gone. So if we change x in here, well, it can't affect this computation. We already did it. If you want a computation to happen later or happen repeatedly, then you always have to box it up in a block. In this case, both this operation and this operation happen repeatedly, so we had to put both of them in a block. In the case of if true, this operation may or may not happen at all, so we had to put it in a block so that it doesn't automatically get computed, even if this happened to be false. Generally speaking, being this sort of brutal about loops, having an explicit condition and while true, usually means you've missed something better. There is usually a better way to do loops. There is this style we showed before for simply looping over numbers, and when we get to containers in a moment, you'll see you can loop over container elements quite easily as well. But just because there's usually a better way doesn't mean that this is always the wrong option. You should consider what is the clearest, what is the most appropriate for the situation, and loop in the way that makes sense.